Hi everyone, sorry for the delay. Linux doesn't like Zoom plugins apparently. My name is Ben Actus, and this is going to be Hardware Hacking 101 in 20 minutes. So the main overview of this one is going to be, uh, this talk is designed for someone with no electrical engineering experience, no hardware hacking experience at all. I just recently got into this a few months ago. And the end kind of goal or takeaway is if you're phenomenal at web application hacking, or you're interested in web app hacking, or perhaps you've dived or played with mobile reversing for bug bounties, how if you spend a little time to gain the hardware hacking skill sets, you'll have more targets available and you can leverage your existing skills with the new hardware hacking ones. It really blew my mind, and I wish I got into these kind of things sooner. So like I said, I want you to learn hardware hacking. I was really against it for a long time. I never really saw the benefit of it. And it wasn't until understanding how a lot of the IoT devices interact with their back-end servers that I said, oh, wait, I can use my same skills and find more vulns this way. A little bit about me. That's a photo of me as a child. I worked at a research lab at the start of my career. I did a lot of network analytics work and reverse engineering of x86 and mobile binaries. Then I worked at an antivirus company, and I did tons of Android reversing there. Then I worked at an offensive company, and that's how I got into the bug bounties. Right now, I work at one of the big four in Silicon Valley. I'm on their red team, so I get to attack everything. And I'm a huge advocate of pushing yourself and not setting limits. Try new things and learn. All of my skill sets I was a novice at the beginning. I'm also at BenRaw on Twitter, or just search Ben Actus. Feel free to reach out and send me DMs. I do answer questions, and I do like getting the messages too. Also, if you need amazing training in hardware hacking, please go check out these two sites, securinghardware.com and toothless.co. Joe and Dimitri are phenomenal instructors. They teach at a lot of the big hacker cons. They can do this way better than me. I'm just a novice here. So outline. We're going to talk about some basic power kind of things, multimeters, soldering, why you need to know that, and how that applies to bug bounties. Then we're going to go into identifying, quotes, stuff here, circuit designs, logic analyzers. Then we're going to finish up with actually more hacker fun stuff, right? Interacting with these kind of protocols, the actual hacking part of it that applies more to your traditional host, web, and mobile hacking skills. And that's your things like UART, SPI, and JTAG. So the first example, say there's a bug bounty program and they ship you some kind of IoT device. And this IoT device is going to be interacting with an IoT cloud infrastructure in the backend. And they're authenticating with some kind of certs. If you just have your traditional web application hacking skill sets, you can just probe. You can set up burp proxy, you can man in middle and systematically start probing things, but you're still limited to that one single device sending or initiating some of that traffic, right? With the hardware hacking skills, what's cool is you will learn how to, like, via SPI or JTAG, interact with the device, physically extract the certs, and then if you get really good, you could even yank the firmware off, figure out what kind of chip they're using, and then build a bunch of little, like, similar mimicking hardware, and all of those then could be used to probe the backend APIs, which is really cool. So it's like going from one little server to being able to spin up like a bunch of little AWS nodes, all to attack something at the same time, which I think is really cool. Another example I've seen is, say there's a little IoT device, right? And prior to learning hardware hacking, the only way I could get firmware to look for vulns is either to get it from the developer, if I could, man in the middle it, right? Which means I'm only getting the latest version they're pulling down or I can acquire. The cool thing is when you get into the hardware hacking stuff, what you can do is you can extract the firmware that came off the little IoT device right from the factory. And what's cool about that is you can take the most earliest instantiation of this firmware, right? Version 0, compare that to the latest one, and then you can do a binary diff. And what's cool about that, and what I've found historically, is when you do diffs like that, whatever's changed is typically things the developers tried to harden or patch, and or that they value, right? So you find interesting things there. So this is where it applies really well too. Okay, basic power stuff. First thing we have is multimeters. For those of you who are unsure what a multimeter looks like, I'll show it at the end. I have all the things on my desk right now. Essentially, it's used for finding ground. This serves a purpose. One, for safety. You don't want to hurt yourself if you're dealing with a lot of voltages or power. Also, you don't want to damage your equipment, right? If you're doing a bug bounty and they send you an IoT device, it's really embarrassing to say, sorry, I fried it because I mixed up 2 wires or 2 connections, right? So here's something. I was sent a mystery device, we'll say here, and it basically used a lot of power. And that made me a little apprehensive. I'm a delicate being. I didn't want to be probing things at the kind of voltages that goes into a wall outlet. But on the right is the actual logic behind this thing. This is the actual IoT that contains the vulnerabilities, right? And what you can see here is in the, where is it? I'll show, oh yeah, right to, let's see, can I show my little thing here? Right where my mouse is, this thing, this kind of dark gray with these 6 prongs, that's where the wall connection comes in. So if I can figure out ground here and which one's getting power, I can make a tiny, safer power supply that's like 5 volts, and I can test everything and do my vuln hunting much safer. So here's a video of me actually doing this. This is the first time. I just came out of a hardware hacking class, like 1 day's worth of training. This hardware hacking attempt 01, filming this in case I start a fire or I fry this or zap myself. Safety, fire extinguisher is here. Okay. Okay. All I gotta do is find the correct voltage for this little thing here. IoT device goes on to this. Once I know the correct voltage, I can use a lab power supply test bench to power this without the scary wall outlet. Okay, so what I'm going to do is, I don't know which one's ground, so I have a fun little multimeter here. I'm going to basically go through all 36 combinations. When I see voltage, it should be around 5 volts according to the markings here, but I just want to double check everything. So plug it in, touch every, or pick one for ground, go through the other 5. It doesn't work, enumerate through the rest. Only real cause of concern is if I somehow touch the 2 prongs, probably will short it. So yeah, we'll find out. Okay, so step 1, plug this thing in. And I have surge protectors, so hopefully not everything dies. And lack of motor skills. Okay, plugged in. Hopefully you guys can see everything. So, multimeter. So we'll assume ground is top left. I'll just go through everything. Okay, here has nothing. Oh, that was incredibly easy. Yeah, 5.5, first try. Booyah. So as you can see there, all I'm doing is, finding my ground, right? And then what voltage to do. And what was the cool thing, let's see, can I get back to that? Then what I did was I built this little tiny power supply. So that's regular college line kind of notebook to kind of give you a sense of size and scale. That's just powered with a little tiny micro USB. So I went from wall outlet to little tiny thing powering it, and then I can do all the traditional hardware hacking kind of stuff. why you have to learn how to solder is because of this right here. You can buy a $80 to like $100 giant lab power supply, which you can adjust power dynamically, or you can spend $5 on Amazon or Adafruit, buy the little SparkFun thing, and just solder it yourself. A few little soldering tips I wish I knew going into this. First one, there's soldering wicks that come with like adjustable wicks on the end that help tremendously. Really saves you a lot of time when there's weird kind of connections and things like that. The other thing is buy a USB microscope if you have bad vision, such as myself. They're like $50 to $30. You can magnify up to like 500 times. Makes your life a lot easier. Now that we can power IoT devices, if we ever have to adjust things, how do we understand what to attach to? First thing is circuit designs. I know this sounds boring. It'll save you a ton of time. All the kind of connections and protocols we're going to talk about in a few minutes, you're going to need to figure out how what to attach to. So if you can read the physical circuits on the board, you can find their diagrams a lot of the time. If you can't, you can be sneaky and check patent information. And if you find it, it's actually kind of cool. I never knew this. All the circuit diagrams actually say what all those little pins mean, right? So like, see how this one says like 11, 10, 9, 8, etc. If you can actually find those, these are the same here. And what you do is they'll actually have a diagram or a table that says these are UART, or these are SPI, or these are JTAG. And it sounds crazy and time consuming, but what you do is once you find the appropriate ones, you'll follow these little lines all the way with your microscope or your amazing vision, and then figure out where you have to hook in. I know, really cool. I never knew that. All right, what happens if you get something and you can't find a circuit manual for it? Well, then you get into logic analyzers. The Saley ones, those are the ones I've used in all the training classes I've taken. I think they're expensive. They're like $300 to $500. Essentially, it's Wireshark for your hardware hacking. What you can do is, once you've figured out your ground or whatever that may be, you hook these little prongs up, and then based on your knowledge of the various protocols, which I'll show you where those tutorials are, you can then make process of elimination or inferences to figure out if it's UART, if it's SPI, if it's JTAG. Then you can hook up your stuff. So once you figure out what the connections are, you have to go about connecting to things. First basic one is called UART. This is the dumbest you can get. It's all it is like ground and transmit and receive. The good news is, since we know how to find ground easy, if you ever mix it up, you just switch two cables. One's receive, one's transmit. And what's cool is then you often get like a console, console interaction, a terminal. So if you can guess a password or it doesn't have a password, you can actually start interacting. It's like a little Linux shell. It's really cool. Other cool things you can do if you don't know the passwords, you can reboot it, and sometimes you can interrupt the boot process, like an older, any kind of Linux machine, right? Where you can boot into like user level 1 as root, then you can edit files directly from there. Downside is it's really hard to copy things off just via UART, because all you have is a kind of terminal connection. What you can do is you could hex dump a file to the screen, and then on your primary machine, copy and paste the raw hex, and then rebuild a binary. It's super gross, but you can do it. Next is SPI hacking. So this is faster than UART, and you can dump flash. That's cool because that's where your firmware and other kind of certificates live, right? So you do need some specialized hardware. So you need typically a Teensy. It's like a little tiny Arduino. And you're going to be either soldering or hooking up these little alligator clips. And I did put some tutorials how to use that, right? It's not too bad. Basically, you're going to program it a little bit, and then you're going to yank everything off, right? It does take some time. Sometimes it can take like 20 or 40 minutes, but you can get your firmware off, which is really cool. And then once you get your firmware, you can kind of do the things I described in the previous steps, right? That's where you're, extracting the firmware. You're doing bin walk. You're looking for certificates. You're looking to see what changed. You're looking for strings. You're looking for weird test URLs or endpoints that may not be otherwise shown to you. So that's SPI. But the coolest thing is something called JTAG. And JTAG is really, really cool because it's, imagine if you had GDB, you know, the debugger, and all the interfaces we just talked about. It's really cool. You can literally say, processor, stop executing instructions, and then interact with memory as things are paused. That includes patching binaries live, right? So for example, maybe there's a router and you're doing some login with it, right? If you can find the process associated with like checking the password, you could patch out password checks. It's really, really cool. The downside is it's a little bit more complicated than the other ones, but there's two awesome examples there. So now at this point, I'm going to switch to kind of more like show and tell kind of stuff I got. So let me start video. Hopefully, can you guys see me okay? All right, cool. So we mentioned JTAG. So JTAG, one of the things to speed up your process to actually understanding what's going on, something called a JTagulator. So this one's a little bit of money, but looks like this. It's really cool. What's cool about it is it's essentially a brute forcer for figuring out what JTAG ports do what, right? So JTAG does have a ton of ports, which kind of sucks. So you could sit there if you're cost constrained with the logic analyzer and gradually try to figure out what's doing what. Or you could have a cup of coffee, hook this guy up, and it'll brute force all the connections that you think are JTAG and tell you which ones work and automatically hook it up. It's pretty cool. Other things I mentioned in the talk, USB microscope, this guy right here, saves you a ton of time, and you hook it up like any kind of webcam. It'll just render really close. I have really bad vision, so it helps me a lot. And not many people are playing with these kind of things. So I know I'm just over time here. So highly recommend you get into all this kind of stuff. The slide deck will be up here. Again, this is just very high level overview of all the kind of examples you can do. There's tons of tutorials online and training. And I highly recommend you look at this because if you're really good at web or you're good at mobile, there is so many additional things you can find from here. You might find new endpoints. You might find the first implementation of their API in firmware somewhere, right? And also, you could also see when you are modifying incoming traffic, how the logic on the actual IoT board is processing that differently, right? So I think it'll save you a lot of time. So I'm just over right now. I'm going to say, Sam, I'm good, ready to take, I guess, Twitch questions.
I think we have some time, actually. Let me see. We've got like 13 minutes until the next presentation.
Cool. No, I'll take questions because I like zoomed through everything thinking I only had 20 minutes here, you know?
Yeah, no worries. No worries. So yeah, we've got about 13 minutes. So if anyone has...
And I can dive into individual things a lot more, right?
Yeah.
Do you have any in the Twitch one?
Yeah, that's what I'm looking at. Cool. I'm just waiting for people to see if they've got any questions.
And getting started with all this stuff, you can start kind of small, right? Like you don't need the JTagulator. You probably just need a multimeter, some of the cables. If you went all out, starting cost about $1,000. If you're moderate, under 500.
Let's see. So someone asked if you're going to share your slides. I think you will, right?
Absolutely.
Yeah.
Yep. Mm-hmm.
Yeah,
I have all the links, and I have a lot more tutorials in there. I can throw in there too. And if you want, I can show you where I bought this stuff. There's some good ones on Adafruit, and then the kind of power supplies and stuff I bought on Amazon too.
Actually, only a medic was just asking what sample devices or kits you recommend.
Oh yeah, what's great is, gosh, a bunch of things, right? So like any of the, I put some tutorials up there. I'd also message the 2 trainer guys I put on there too. Often anything where you have control of like the hardware and like open source software, right? Like you could, you know, you can put like, what's it called? OpenWRT on a lot of different like Raspberry Pis or Arduinos or like custom hardware. Something like that would be cool because then you can control everything and you could just walk through all the different examples, right? Like a UART one, see what you can do. And you do SPI, see what you can do. Then you do JTAG, see what you can do. And then I would just start looking at like, if BugCrowd has opportunities, look at that. If not BugCrowd, look for a discontinued product on like Amazon, right? Where they went out of business for a reason, and then load it on there and just see what you can find. You'd be really shocked, especially dumping firmware. Like from a first generation firmware to when they push a new one down, you'd be really surprised what things they might forget.
All right. Let's see. Danza York asked, are there any good vulns that you found that you can talk about?
I don't know if I can talk about things. I will say that you would be surprised. Oh, here's a good one. So I was taking class. I asked the instructor, I was like, hey, like a lot of these companies, like I have friends who work at these places, they say they disable JTAG. So it's not even worth me finding it. And he was like, well, you might want to look what disable means. That might be a thing where you might have to solder a little piece of metal onto it to re-enable it, right? Or disable might mean like I might have to take out 4 screws and then flip the board upside down, right? So a lot of it you'll see, and JTAG is often enabled a lot on consumer devices, right? Because like when a device is damaged and they got to ship it back to the factory, they need to test stuff, right? So think of it, for example, if you're a factory technician and you get something, you need to do diagnostics with easy access, right? So having said that, if you have a device and you don't know what something means, but if you take 1 screw and like 8 pins are easily accessible, probably has something to do with a diagnostic, right? So that's why I would then check those for your, on the logic analyzer, for JTAG, SPI, UART, etc. Right? I'm trying to think of other good ones. Those are the interesting things that I found that came to mind.
What would you say is the like rough typical amount of money someone should expect to spend to just kind of get started? Like, say I just watched this, and I'm like,
so the logic analyzer is going to be the most money, right? So there's like weird, sketchy knockoffs, but the downside is if you're learning and you get like a crappy, sketchy knockoff, that might throw off your results, right? So like you could be doing everything right, but then you're getting wrong readings, which would be really frustrating. So the logic analyzer is probably going to be your biggest investment, right? The cost there. The other thing you could see if there's like a hacker meetup or one of those, hacker labs near you. I'm sure they have these things already, or any kind of electrical engineering community college or something that surely has these things. So you could hopefully, use them to get started. But yeah, the logic analyzer is going to be your probably most expensive initial purchase. Everything else is $10 here, $20 there.
Nice. Let's see if anyone else. Casey Ellis asks. We're going to take an audience question here.
Yeah.
Casey Ellis, he asks, have you started tinkering with cars?
No, but that would be really cool because so once you learn these things, everything builds, right? So CAN bus is how the when you drive, you got to get the silly the environmental protection test done for your vehicle. You hook into that. That protocol is well known. So if you were playing with a car thing and you saw connections that you didn't know, same kind of things apply here, right? Do they have JTAG enabled? Is there SPI? How do I understand the protocol? What's being sent, right? Because usually when you do these logic analyzer captures, you essentially say capture for this many seconds and then you do something. Maybe you turn on power or whatever. And based on these protocols, all the different signals will look a particular way when like it initiates or does something or receives something. And that's how you can figure it out. CAN bus is really interesting, right? Because what's cool is all these protocols, they were designed in an era before like people like us looked at it, right? So it's really cool. And now they're getting better, but there's a lot of really old things still out there, which is cool.
Dude from somewhere too says it sounds like Ben wants to do a car talk.
So like I have my car right? And I mean, I have airbags. I guess as long as the airbags talk, or, right? Or test things. That would be fun to do, right? I mean, I think automotive stuff is always interesting. I think it's hard to also test because like you don't want to test in your car. So that means you gotta rent a car. You know what I mean? Or go to the dealership.
Yeah, exactly.
Like I like to sit in cars silently with my laptop for 30 minutes before I purchase one, right? And then just not bother.
Yeah.
So yeah, that's the downside. The other thing, I should take this back. The other thing you could do, my buddy John did this. He found he would go to junkyards, and junkyards usually pay per pound, and he would just like literally in a pickup truck buy a totaled vehicle because he just needed some of the components. You know what I mean? It didn't need to run. He just had to supply power to it. That's a way you could do it cheaper, actually.
Yeah, that's what. There's a guy named Alan Mond.
Yeah,
He does that.
yeah,
He picks up CAN buses and
yeah.
dashes and stuff like that.
Yeah, because basically what you're doing is you're learning how to read it. You're learning how different signals interact with other components, right? And then it's just tracing everything, right?
Yeah, totally. Yeah, Casey shared the link. He actually, Alan gave a talk last year at LevelUp about car hacking, and his website is carloop.io.
Hmm. And I would encourage everyone to look at this stuff because you look at all the new areas and everything's interacting. Car hacking, CNC milling machines, right? For your wood shops that drill wood or metal. All these things interact on these older interfaces, right? And if you learn these skills, you can analyze and play with all of this.
Let's see. Well, we'll see if there's any more questions. But yeah, for those that are watching and not watching the chat, we have tweeted out links to everyone's Twitter account, including Ben's, so you can follow Ben on Twitter. And I'm sure you'll share links to stuff. And
Yeah,
then
I'll throw all this
also,
up after
yeah,
this.
we'll put I'll take the links to that and I'll put that in the YouTube description and stuff like that when
Yeah.
this goes up to YouTube.
Yeah, and I'll also add all the parts list, the stuff I bought, and then I'll keep updating this with better tutorials and stuff like that too.
Awesome.
Yeah,
Well, I think we're gonna wrap there, and then we'll get ready for our last presentation from John.
cool. Well, thanks everyone. Have fun.